This video will cover congruence in geometry, and before we get started on some old Common Core geometry questions, we will talk about a couple important pieces of information regarding congruent figures. In terms of congruent figures, they have the same size and shape. Same size, same shape. Then we have these 5 different methods to prove triangles congruent. All of them, except for the last one, have S's and A's. S meaning side, and A for angle. So the first one, we have 3 pairs of sides congruent. Again, pairs meaning this side is a pair with this side. So that's 1 pair of sides congruent, and we need all 3 pairs, side, side, side. The second one, we have side, angle, side, where the angle is in between your two pairs of congruent sides. The next one, we have angle, angle, side, where your side is touching simply 1 angle, so this side touches 1 pair of angles. The next, we have angle, side, angle, where your side is between your 2 pairs of angles. And then the last one that we have is HL. H for hypotenuse, and L for leg. And these can only be used with right triangles, HL, where we again have hypotenuse and then the legs. We have a couple different methods for proving parallelograms. You'll see that there are some Common Core questions that ask you to prove parallelograms. These are based off of the fact that we have some properties of parallelograms. In order to prove a parallelogram, we can either prove both pairs of opposite sides are congruent, both pairs of opposite sides are parallel, or just 1 pair of opposite sides is both congruent and parallel. And then lastly, diagonals bisect each other. In other words, they cut each other in half. Down here we have some important proof steps. Sometimes you'll get to use these vertical angles. They're like a bow tie. You can say that they are congruent to one another because vertical angles are congruent. We also have a property called the reflexive property. Reflexive just means it's a side or an angle that's shared or in common between your 2 triangles that you're trying to prove. So we just say that BD is congruent to itself because of the reflexive property. Next we have a bisector. AD bisects BC at E. Bisectors cut segments in half. So these 2 segments, BE and CE, are congruent because of this definition over here to your right-hand side. Next, we have BD bisects an angle. Angles are cut in half, or an angle is cut in half to create 2 congruent angles. So we state those angles are congruent, and then our reason again over here on your right-hand side. Then last but not least, we have this upside down T. Upside down T means perpendicular. And perpendicular lines give us right angles, which you can see marked up here. Those right angles. We state that they are congruent, and then the reason is that perpendicular lines form congruent right angles. The first question that's coming from a Common Core exam is similar to what you saw in your last packet of transformations. It says after a reflection over a line, triangle A prime, B prime, C prime is the image of triangle ABC. Explain why triangle ABC is congruent to triangle A prime, B prime, C prime. If you recall from last time, a reflection preserves distance. So we're just going to start with saying a reflection over a line preserves distance. Creating congruent figures. Remember again, just like the last time, we have to be specific. We have to make sure that we talk about that reflection over the line and preserving distance. These are 2 things that they're looking for to get your 2 points here. Remember that you are welcome to pause this video at any point in time to try these problems on your own and then check back in with me. I actually highly suggest it so that you can get some practice independently and then just get the feedback from the videos. because again, you are expected to be able to answer these questions on your own when you take that test in June. Number 2 says, which statement is sufficient evidence that triangle DEF is congruent to triangle ABC? Remember, our options include side, 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 angle, side, angle, angle, side, angle, side, angle, and HL. But clearly these are not right triangles, so I'm just going to cross HL off of the bunch here. So if we read through these, we could mark up the picture if you want to. You will have to erase so that you can try to mark up the next one. So be prepared with a pencil to do this. AB is equal to DE, and BC is equal to EF. So this here is just side, side, which is not enough information to prove, so I'm going to erase my markings and move on to the next one. Next we have angle D is congruent to angle A, B is congruent to E, and C is congruent to F. This is angle, 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 which is not one of our 4 choices down here. So 1 and 2 again are out, which means I'm erasing. And now we're reading the next one. It says AB is mapped onto DE. So that means AB, the whole segment, moves on to DE, meaning that they're congruent. BC onto EF, and AC onto DF. So this one, side, side, side. 3 pairs of sides marked congruent, which is a choice. So I'm going to choose choice 3, but I want to talk about why choice 4 is not the answer. Because if you worked from the bottom up, you might have chosen choice 4. It says that point A is mapped onto point D. So I'm just going to put my point A, point D. AB, the whole segment, is mapped onto DE, the whole segment. And the whole angle B is mapped onto the whole angle E. Now you might be thinking that this is ASA. However, they said nothing about the actual angle A. So I'm going to take a second and kind of resketch this here, just kind of draw it out a little bit more. I'm going to keep this part of the triangle exactly the same. So segment AB is still congruent to segment DE, and angle B is still congruent to angle E. But instead of having C placed right here, I'm going to place it out over here. So now my triangle looks like this. I still kept those angles congruent and those sides congruent just like they wanted. And I still kept angle A mapping onto angle D, however C is extended, which means that this triangle here in black, AB with this new C, is no longer congruent to this triangle over here, DEF. So choice 4 is not the answer because this part where it says point A onto point D is not enough or not sufficient evidence to prove triangles congruent. Number 3 was I believe a 4-point question on a Common Core exam. It is a proof, so I'm going to start the T-chart here. In these T-chart proofs, remember that you have to copy down the entire given statement for your first step. I'm going to save us some time and not copy it down, but understand that this whole entire thing would have to be written on your exam, with the reason being that it's given. Now we have a parallelogram with diagonals AC and BD intersecting. When we are given a parallelogram and asked to prove some triangles congruent, we often have a lot of options. I'm just going to take a second to highlight those 2 triangles that we actually care about. Oops. Maybe you would like to do the same. Okay, so it says that we want to prove triangle AED is congruent to triangle BEC, or CEB rather. You can see that I highlighted them very lightly, just so that we can look at those properties of a parallelogram to help us prove these little yellow triangles are congruent. So when we have a parallelogram, we know, oops, wow, that's really big. We know some stuff about those opposite sides. So we're going to start with that. Step 2. AD is congruent to BC and also parallel. I want you to get into the habit of stating congruent and parallel at the same time when you have a parallelogram. This way, if you talk about alternate interior angles later, you don't have to state parallel again because you've already stated it, or you don't have to remember to state it because often students forget. So we're going to say AD is congruent to CB, comma, AD is parallel to CB. And this is because opposite sides of a parallelogram are congruent and parallel. So then the next step is to find some more information based off of the fact that we have a parallelogram. And if you recall, a way that we could prove that things are parallelograms is by showing that the diagonals bisect each other. So that's actually a property of parallelograms. So I'm going to state that AE is congruent to CE and also that BE is congruent to DE because we know diagonals bisect each other. AE is congruent to CE, DE is congruent to BE. And again, this is because diagonals in a parallelogram bisect each other. So now looking at my picture, it looks like I have one pair of sides, another pair of sides, and a third pair of sides. So here we are ready to prove that triangle AED is congruent to triangle CEB by side, side, side. This is not the only method of proof. We could have also chosen to talk about, say, alternate interior angles or vertical angles. You could have done this proof in many ways. Okay, so side, side, side is not the end-all be-all here. You could have done angle, angle, side, or angle, side, angle. Just not HL. There are no right angles here. The next part to this problem says describe a single rigid motion, meaning one single transformation that preserves distance that maps triangle AED onto CEB. So if I want A to map onto C and D to map onto B, you can see that this is a turn. Or in other words, a rotation of 180 degrees. But notice I left this little spot here. This is because we need to put the point that we're turning around. If A has to map on a C, D has to map on a B, that means E is mapping onto itself, which means that E is our point of rotation. Rotate around E 180 degrees. Another option here, because we have something that's the same as a rotation of 180, remember that reflection through the origin? Well, unfortunately, we don't have an origin here, but we have a point. Reflection through point E would also be a valid reason here. This next question was a proof on the Common Core exam in January 2016. It's a kind of tricky question. It is a proof that asks you to prove two different things. So it's a little bit lengthier than the average proof that you just saw on the last page. So we're going to start with statement and reason. On your exam, you would be writing this entire given right here in number 1. We will again skip it right now just to save some time. Step 2, we're going to use the fact that we have a parallelogram because we are trying to prove that triangle ANW is congruent to triangle DRE. So let me again highlight those just like I did the last time. At least I'm going to attempt to. Instead of highlighting, I'm ending up coloring. Okay. So we care about those two little triangles right here in order to prove that the triangles are congruent. We need to use the properties of parallelogram. So first, just like the last time, we're going to talk about these opposite sides that are both congruent and parallel. And even though I don't necessarily need this whole side, DN, or this whole side AR, we're still going to talk about them because maybe it'll help us later. So I'm just marking right now congruent and parallel. And then now I'm going to state it. So we're stating 4 things in statement number 2. We're stating that AN is congruent to DR, and AR is congruent to DN. Then we're going to also state that they are parallel. AN parallel to DR, AR parallel to DN. And this is because opposite sides of a parallelogram are congruent and parallel. Next, we know in a parallelogram that opposite angles are congruent. So for the statement number 3, we're going to say angle N is congruent to angle R. And this again is because opposite angles in a parallelogram are congruent. So right now it looks like we have a pair of sides and a pair of angles. Remember, in order to prove triangles congruent, we need 3 pieces of information. So we also have the fact that we have a bisector, actually 2 bisectors, DE and AW, which means now that we have AE, 3 hash marks, is congruent to RE, and DW is congruent to NW. Now you might be asking, why did I not use 4 hash marks over here on this side? The reason is because, remember, opposite sides AR and DN are already congruent. So say this length out here is, I don't know, 10. So that means the other one's 10. Well, if I cut it in half, AR cut in half at E, this means this is 5 and this is 5. If I do the same, cut DN in half at W, then each of these pieces are 5, which means that they're all congruent to one another. So we're going to state that in number 4. All 4 of those pieces are congruent to each other, so we're just going to have one big chain going. RE is congruent to EA, is congruent to DW, is congruent to WN. Now our reason here gets a little goofy. What we're going to say is that segment bisectors divide. Normally we say a segment into 2 congruent segments, but instead of a segment, we are dividing 2 segments into 4 congruent segments. So we're just going to adjust that reason. It's okay to do that. Segment bisectors divide 2 segments into 4 congruent segments. Alright, so now if we look at this, we have SAS, right where this 5 is, I'm covering up with an S. Same with this other one, we have SAS. So now our triangles are congruent. That's our first proof. Triangle ANW is congruent to triangle DRE. And again, that is by SAS. Now our next step is to prove that prove that quadrilateral AWD, right in here, I'm shading it in purple, is a parallelogram. So this comes back to what we talked about on the front side of our notes here, where we have 4 different ways to prove that parallelograms are, in fact, parallelograms. And the first way was that both pairs of opposite sides are congruent. So if we look at this picture, we already have 1 pair of opposite sides congruent. So I believe that we could get this other pair of opposite sides congruent, based on the fact that those yellow triangles are already congruent. If I know that the triangles are congruent, then it's safe to say that DE and WA are also congruent. The reason being, again, the triangles are congruent and these are corresponding sides. So we're going to say for number 6 that DE is congruent to AW. There's a lengthy reason for this, or there's a 5-letter reason for this. The 5-letter reason is CPCTC. and then I'm going to write it out for you. It stands for corresponding parts of congruent triangles are congruent. So again, those corresponding parts, those corresponding sides, DE and AW, of those congruent triangles in yellow are now congruent. So if we look at this picture of that purple parallelogram, we have AE congruent to DW and DE congruent to AW, which means that that parallelogram, that quadrilateral, is a parallelogram. Quadrilateral AWDE is a parallelogram. And this is because parallelograms have both pairs of opposite sides congruent. So again, if we can get both pairs of those opposite sides of a figure congruent, then it must be a parallelogram. Remember that you can go back, you can rewind, you can pause, you can do whatever you need to with this video to help yourself prepare and plan to be successful in June on your retake. You do have quite a bit of practice to do before you take your assessment. So again, rewind, pause, go back, take notes as you're going through these videos.